Hi, this is Mrs. LaBarbera. This is Physics Chapter 12, Sound and Light, Video 4. Today's topic is refraction of light. The objectives are know the definition and cause of refraction, understand conditions of refraction, be able to select sketch diagrams of refracted rays as they pass between two or more media, be able to determine direction in which rays bend based on change in speed, and be able to use diagrams to determine relative speed of the medium based on the direction of rays. Refraction of light waves. Refraction is the bending of a wave as it passes at an angle from one medium to another. When a beam of light approaches the boundary at an angle, we also call that obliquely. It changes directions as it across the boundary separating the two medium. This is over here, the diagram shows the light entering a boundary obliquely. So the amount of refraction of ray is measured by the angle of refraction. So in this case, the angle of refraction is the angle of refracted ray with the normal. So in this case, that's R. Note the angle of refraction and angle of incidence are on the opposite side of normal. So if the angle of incidence is on the left side, refraction has to be on the right side. So when angle of incidence in this case is on the left, the angle of refraction has to be on the right. So light does not change directions when it goes straight down. There is no changing directions over here. Why does light change directions, or why does wave change directions? So we talked about this before. Let's just reiterate what we have talked about. When the light changes medium, first thing we know its speed changes because the only thing determines the speed is the medium. While its frequency, however, stays the same, it always stays the same as the source. So let's see what happens when light enters a new medium at an angle such as this animation. Part of the wavefront right over here, this part was change the speed. In this case, it's kind of like slowed down. The other part, since it's not in the change the medium yet, so that part is still going with the same speed. Okay, this is why light bends. While the other part of the same wavefront will not change its speed because it has not reached the new medium. So light bends because different part of the wavefront has different speed. That's different, okay? However, when the light wave approaches the boundary in a direction which is perpendicular to it, goes straight down like this. See, now light does not bend. It's bending of light, bending, no bending. That is because all the points on the wavefront have changed the speed at the same time. There is no part speed is faster or slower than the other part. Every part is the same. Direction of bending. The speed of light wave is dependent upon the optical density of the material through which it moves. Light travels faster in less optically dense medium. So if a ray of light passes across the boundary from a denser to less dense, so it's going to speed up. Because it's going to speed up, it's going to actually bend away from the normal. So this blue is denser, this one is less dense. Now, if the rays passes from across the boundary from less dense to denser, when you're going to denser, you're slowing down. As a result, you're going to bend toward normal. Okay. Note the incident ray and refracted ray are again on the opposite side of line of normal. Let's take a look at this animation. So here is less dense to, let's see, denser to less dense, you're bending away. Less dense to denser, you are moving toward. By the way, these rays are reversible. If I shine a light this way, it's going to bend this way. That's what this animation is saying, okay? Refraction and visual distortion. You probably have all seen this, like a pencil that's bent. Why does a pencil bend? Why? When you have a penny on the bottom of the cup, and it looks like the penny is on the top. Okay. This is why the rays bend, but as from your eye, seems like the light is same thing for the pencil over here. Let's take a look at atmospheric refraction, visibility of the sun. Because the density of the Earth's atmosphere increases gradually as the Earth's surface is approached from space, as sunlight approaches from space, all that enter this layer, the different layer has different density. So the light is going to have different speed. Therefore, it's going to refract. That means bending. So the light doesn't actually travel in a straight line when it comes into Earth. However, your brain has learned to assume light enters your eyes has been traveling in a straight line. Thus, the sunset or the sunrise you see actually is higher in the sky than it actually is. Let's take a look at this.
Now, this is very interesting. You get to see the sunrise before the sun actually rises. You know what happens? Earth's atmosphere has different layers. And also, the optical densities of these layers decreases as you move away from the Earth's surface. That is with increasing height. So, what happens is, just before sunrise, before the sun reaches the horizon, the sunlight enters obliquely into the atmosphere. It gets refracted through the atmospheric layers. Now, this refraction causes the light rays to bend. So the sunlight actually reaches the Earth's surface in a curved path. Now, what happens from the point of view of an observer? Following the path of the light rays entering the eyes, the observer actually sees the sun slightly above its actual position. And as a result of that, he sees the sun about 2 minutes before the sun actually rises.
Okay. Let's take a look at image formed by lens is also refraction. So like some of you, I'm nearsighted. So this is what happens. I can't see the image clearly without glasses. In order to see the image clearly, I have to modify the rays by using a lens, concave lens. The concave lens can spread the rays. So this rays will reach the retina of the eye so I can see clearly. And some of you may have farsightedness or long-sighted. This is another case you can't see the image clearly because it falls in the back of your retina. So you use lenses to correct this. And this lens actually focused rays on the retina. So both of this case, we're using the lens to help us to focus light, to focus the image on the retina. Next one is dispersion, refraction of white light. So the separation of visible light into different colors is known as dispersion. So you shine the light through a prism, you will see, obviously you don't see all the light, each individual rays, but you will see a rainbow formed right over here. Why is that? That is because the wavelength actually affects the index of refraction. So on your reference table, you say, wait a second, we have only one index of refraction for light, but that is really the yellow light. Yellow light kind of like in the middle, so we take the average. So when you see in your question, it may say the light with the frequency corresponding to the yellow light enters a glass or some other diamond. So that means you can use the index of refraction. So the dispersion happens is because the wavelength, the waves with different wavelength get dispersed differently. Let's do a couple of questions. First, In the diagram, a ray of monochromatic light and a ray of polychromatic light are both incident upon the air-glass interface. Which phenomenon could occur with ray B but not with ray A? Let's see what's the difference with B and A. It's just one is polychromatic, means multicolored, the other is one color. So think about what is the answer. Well, the answer in here is dispersion, because dispersion is separation of colors. So they are both reflecting because it's light waves. They can be both be polarized and they both can refract. The only difference is B can be dispersed because it has different colors. A cannot be dispersed because A has only one color. Another example. The diagram shows a ray of light passing from air into glass at an angle incident of 0 degrees. That means goes straight down. Which statement best describes the speed and direction of the light ray as it passes into glass? Well, we know when the light goes from one medium to another medium, its speed changes. But in this case, the direction does not change because you're going straight down. So all the parts of the wavefront slows down at the same time. So the answer is A, only speed changes. Another example, the diagram shows how an observer located at point P on Earth can see the sun when it is below the observer's horizon. This observation is possible because the ability of the Earth's atmosphere we just talked about this, to refract light, because the atmosphere has different layers and different layer has different density. So as a result, the sunlight actually bends, doesn't travel in a straight line. That's why we see the sun before the sunrise and we see the sun after sunset. Which phenomena of light accounts for the formation of image by lenses? So lenses helps us to see. What lenses does is bending the light. Bending the light is refraction. Next example, what is the angle of incidence and what is the angle of refraction in this diagram? The angle of incidence is 27 degrees. Remember, everything is measured with a normal. So here's 27, that's the incident ray. And angle of refraction is 41 degrees. Again, it's the angle with the normal. That's it for today. Thanks for watching.